Hey guys, welcome to our last flipped video lesson. We're going to be tackling target 2. We've been on target 1 for a while because target 1 was kind of broken up into a lot of sub-targets, but we're just going to have one lesson to cover target 2. And we're going to be working on writing equations verbally and algebraically. If this sounds familiar, that's because we did this with expressions back in the first unit. So let's get started here. So our first part of our target is going to be to translate from algebraic into verbal written sentences and vice versa. Now, so far, mostly everything we've done with equations has been solving. And hopefully we've noticed that all an equation really is two expressions joined together by an equal sign. Right? So we just have an expression left and an expression right. We stick an equal sign in the middle. What this really means, though, when we're writing our algebraic sentences and translating, is all the language we learned back in Unit 1, we're going to need to remember. We're going to bring back when we're writing our equations. So hopefully we remember these phrases here. Take a look. We've got a lot of phrases. This was the exact same list that we saw in our video from Unit 1. If you need to, take a second, pause the video, make sure that you refresh your memory on our phrases for addition, subtraction, multiplication, division, exponents, parentheses, all that good stuff you're going to need again when we start writing our equations. When you're ready, go ahead and unpause the video. So, this is a pretty long list, but there are still a few more phrases we need to add here because when we're working with equations, we need something that's going to describe an equal sign, right? Now, we're going to see an example below. We're going to go through kind of a list of phrases which would communicate to somebody that they need to write an equal sign. So you can see a number plus 2 is 8. A number plus 2 is equal to 8. A number plus 2 is the same as 8. And a number plus 2 is equivalent to 8. All of these capital lettered, bolded, underlined phrases all mean the exact same thing. They all mean equal. Write an equal sign. Take what's on the left, put an equal sign, then go on to what's on the right. Well, now that we've got that out of the way, we pretty much have everything we need to start translating. So we're going to start with a sentence, and we want you to write it with numbers, variables, and symbols. No words allowed here. So go ahead and pause the video and try and write an equation for each of these sentences. Ready? Pause. Welcome back. Let's see how we did. So take a look. Most of these expressions here should look pretty much identical. Your expression should look pretty much identical to what I have. On number 4, you might have put x over 3 instead of 1/3 x. But for the most part, guys, we really should end up with the same equation for everybody when we're translating from a sentence to an equation. There are some loopholes there, but 95% of the time, we should get the same exact equation. While we translated from a sentence to an equation, let's now go the other way. Let's take an equation and translate that into a sentence. And remember, this is the situation where there are lots of possible correct answers here. But you are not allowed to use any numbers, and you're not allowed to use any symbols. I'll let you use the letters for a variable, but if you're going to use a number or you're going to use a symbol, you got to write a word or a phrase for that. So pause the video and give each of these a shot now. Welcome back. Let's see how we did. Now remember, the sentence that I have there is a correct answer, not the correct answer. You might have something that's a little bit different, and it might be completely correct. So if you're confused on whether your sentence is accurately translating from an equation to words, please make sure you write that question down and bring it to class tomorrow. For that matter, any questions you've had so far on our translating or our language, please make sure you ask about in class. Well, that brings us to our second part of our target here, and that's to actually take a real-life-like word problem and translate that into equation. So no longer are we going to be taking something that is directly describing an equation and writing an equation. We're going to be taking a paragraph here or a couple sentences that describe a situation, give us some information, and we've got to take that information and piece it together in an equation. This is a little bit more difficult. So let's break these first two down step by step. So in our first example here, Scott has decided to start his own business selling leprechauns. I think that's a great idea. I mean, honestly, who wouldn't want to have a little leprechaun walking around hanging out with them all the time, especially if they're, have a huge pot of gold somewhere. It can make you rich. So he's going to be buying them from Ireland, right? So it takes a while to ship over here. And he's going to sell them for $60 a piece. but the shipping costs to send a batch of leprechauns over from Ireland is $500. Now, if Scott made $1,500 selling these leprechauns, the question is, how many did he sell? Well, what we have to start with, and what is always a good thing to look for, is a total. Is this problem describing something where we are totaling something? And we can see we are told he has a total profit of $1,520. So one of the first things to do when you identify a total is to put that total on one side of the equal sign. Since we know it's a total, the other stuff on the other side of the equal sign is going to be combining to equal that $1,520. Now, how do we get $1,520 of profit? Well, he's got to sell something. He's selling the leprechauns. We don't know how many leprechauns he's selling, so we'll make leprechauns our variables. And for each leprechaun he sells, excuse me guys, for each leprechaun he sells, he's going to make $60. So how do we represent how much money he's going to make selling X leprechauns at $60 a pop? Well, we multiply them. 60 times X, 60 times the number of leprechauns. But that's not our full equation, because there's still one more piece of information here. He's making $60 for each leprechaun he sells, but he is going to lose $500 in the shipping costs. So we have to make sure we take $500 and subtract it from that 60X to accurately represent the right-hand side of that equation. So if he sells a leprechaun, he makes $60. We take all of that money and we take $500 away to cover the shipping costs, and that's going to equal his total of $1,520. Now we have an equation that we could solve to find the number of leprechauns. Let's look at one more example together here. So Emily went shopping for some new clothes this weekend, and she saw some awesome alligator skin shoes, right, for $30 each, which is a pretty great deal. And since they were such a great deal, she went nuts, and she spent $360 on her shoes. Well, how many did she buy? We want to write an equation to solve this. Again, we see a total there. $360 is the total amount of money that she spent. So again, let's put that on one side of the equal sign. Now, what did we do on the other side to get that total? Well, we have $30 per pair of shoes, and we don't know how many shoes she bought, so again, we're going to make that our variable, X. So how do we represent how much money she spent on shoes the same way we represented the number of money Scott made per leprechaun? We wrote it as 30 times X. That'll tell us how much money she spent on shoes, where X is a number of pairs of shoes. And again, now we have an equation, a one-step equation, that we could solve and find how many shoes Emily did buy. Now that we've gone through a couple together, we have a problem here about Leo getting a part-time job and Kat collecting some stuffed porcupines. We want you to try on your own. Your goal is not to solve an equation, but just write an equation which would help us find whatever it is we're being asked to find in each problem. So go ahead and pause the video and give it a shot now. Let's see how you did. Did we end up with 5x plus 55 equals 335? Or x plus 67 equals 213? Well, I hope you did. But if you didn't, and this is still confusing, please, please, please put a big question mark on your notes, and let's ask tomorrow, and we can walk through these and try some more examples together. That brings us to the end. Well, I hope in the game of understanding, translating equations and writing equations from word problems, you were the home team and not the visitors team. But if you're the visitors team, don't worry. We have an extra overtime period tomorrow where we'll make sure we get you caught up and get you ahead in the score. We'll see you then, guys.